Okay, so now we will see folic acid. Uh, this is the first unit of paper 603, that is enzymology. We have seen in enzymology role of cofactors in metabolism, then vitamin niacin, vitamin riboflavin, vitamin thiamine. Niacin have the coenzymes NAD and NADP. Riboflavin have two important coenzymes, FMN, flavin mononucleotide and flavin adenine dinucleotide. Then thymine have the active coenzyme, thymine pyrophosphate. Then we have seen biotin have the active coenzyme biocytin. Then we have seen we have seen vitamin coenzyme A. Coenzyme A is coenzyme of vitamin pantothenic acid. Pantothenic acid is most important coenzyme, most important vitamin having the coenzyme A, that is A for acetylation. A for acetylation. That is coenzyme A have the important role in metabolism. It is the central molecule in metabolism. Then today we are going to see the next vitamin, that is the folic acid. Folic acid or foliacin, that is Latin folium, is abundantly found in green leafy vegetables. This vitamin is present in green leafy vegetables. It is important for one carbon metabolism. Folic acid is important for one carbon metabolism and is required for the synthesis of certain amino acid, purines and pyrimidine thiamine. Folic acid is required for the synthesis of purine and pyrimidine synthesis. Then in one carbon metabolism. These are required for one carbon metabolism. Folic acid, which is also known as foliacin, that is vitamin present in the folium, that is leaves. It is abundantly found in green leafy vegetables like spinach. Spinach contain folic acid. It is important vitamin, have the active coenzyme which is involved in one carbon metabolism and is required for the synthesis of certain amino acid, purines and pyrimidines. So what is the occurrence of folic acid? Folic acid is widely distributed in nature. It is widely distributed in nature. The rich sources are green leafy vegetable, whole grains, cereals, liver, kidney, yeast and eggs. Rich source of this vitamin is whole grains, cereals, liver, kidney, yeast, and eggs. Milk is the poor source of folic acid. Milk is a rich source of vitamin riboflavin. Folic acid consists of three components. First is pteridine ring, then para-amino benzoic acid and glutamic acid. Folic acid consists of three components. First is pteridine ring, made up of pteridine ring, which is joined to para-aminobenzoic acid, which is joined to glutamic acid. Glutamic acid is the amino acid. So folic acid mostly has one glutamic acid residue and it is known as pteroyl glutamic acid. It is known as pteroyl glutamic acid. Consists of three components: pteridine ring, para-aminobenzoic acid and glutamic acid. The active form of vitamin is tetrahydrofolate. Active form of this vitamin folic acid is tetrahydrofolate, THF or FH4. H4 म्हणजे 4 हायड्रोजन and F means folic acid. So it is tetrahydrofolate, THF or FH4, that is the tetrahydrofolate. It is synthesized from folic acid by the enzyme dihydrofolate reductase. Tetrahydrofolate is synthesized from the vitamin folic acid by the enzyme dihydrofolate reductase. The reducing equivalents are provided by the two molecules of NADPH. NADPH provide hydrogen, so folic acid is converted to tetrahydrofolate. Two molecules of NADPH are involved. So two molecules of NADPH gives 4 hydrogen atom to folic acid. So folic acid is converted to tetrahydrofolate. The hydrogen atoms are present at the position of 5, 6, 7, 8 of tetrahydrofolate. Hydrogen atom कुठे present असतात? 5, 6, 7, 8 position. So pyridine ring, this is the pyridine ring. Then uh, this is a this is the teichoic acid moiety, and this is para amino benzoic acid, which is called as the teichoic acid. Pyridine ring amino acid glutamate, and it forms the structure folic acid. So folic acid consists of, see here, folic acid consists of glutamate plus steroic acid, and steroic acid in turn it is made up of two components, pteridine and para amino benzoic acid. So this folic acid, it undergoes reduction reaction by the enzyme dihydrofolate reductase to NADPH provide hydrogen atom, and it is converted to NADP plus, and folic acid is converted to 2 hydrogen from NADPH, and these 2H plus, that is 4 hydrogen atoms are provided to folic acid, and it is converted to 5, 6, 7, 8 tetrahydrofolic acid. It is converted to tetrahydrofolic acid. So see here, joining of hydrogen to fifth position, to sixth position, seventh position, and eighth position. Joining of hydrogen 5, 6, 7, 8 tetrahydrofolic acid. So this is the active form coenzyme of vitamin folic acid. Its active coenzyme is 5, 6, 7, 8 tetrahydrofolate, or 5, 6, 7, 8 THF, or FH4, that is the folate, H4, that is the tetrahydrofolate. 4 hydrogen atoms are joined to 5th, 6th, 7th, 8th position to convert folic acid to tetrahydrofolate. Now what is the biochemical function? Tetrahydrofolate, PHF or FH4, is the coenzyme of folic acid. It is actively involved in the one carbon metabolism. It is involved in one carbon metabolism. One carbon metabolism म्हणजे फक्त वन कार्बन मॉलिक्यूल असलेले, वन कार्बन युनिट असलेले मॉलिक्यूल ते ट्रान्सफर करतं. THF serves as the acceptor of or donor of one carbon unit. वन कार्बन युनिट कशामध्ये असतो? एकच कार्बन कशामध्ये असतो? फॉर्मिल, CHO, that is the formyl. Methyl, that is CH3. Like this way, in which atoms there is only one carbon is involved, that groups are transferred by the folate, tetrahydrofolate, in the metabolism. And there are the variety of reactions involving amino acid and nucleotide metabolism. Amino acid आणि न्यूक्लियोटाइड मेटाबॉलिझम मध्ये ह्या रिएक्शन्स आहे. कोणत्या रिएक्शन? ज्या रिएक्शन्स मध्ये टेट्राहायड्रोफोलेटची इन्व्हॉल्वमेंट आहे. कोणत्या रिएक्शन्स मध्ये टेट्राहायड्रोफोलेटची इन्व्हॉल्वमेंट आहे? रिएक्शन्स इन्व्हॉल्विंग अमायनो ऍसिड अँड न्यूक्लियोटाइड मेटाबॉलिझम. So this include transfer of one carbon, and one carbon unit is present in formyl, methyl, and most of the components. one carbon unit bind with the tetrahydrofolate at position N5 or N10. वन कार्बन युनिट कुठे बाइंड होतंय? ॲट द पोझिशन N5, नायट्रोजनच्या 5th ॲटमला किंवा 10th नायट्रोजनला वन कार्बन युनिट बाइंड होतं, or sometime N5 or N10 of the pteroid structure. The attachment of the formyl at position 5 of the tetrahydrofolate, it forms N5 formyl tetrahydrofolate, which is commonly known as folinic acid or citrohorum factor. काय आहे रिएक्शन? The carbon unit are you getting me? Tetrahydrofolate or folic acid, that is the coenzyme of folic acid. It is involved in one folic acid is involved in one carbon metabolism. So this THF serves as the acceptor or donor of one carbon unit. वन कार्बन युनिट कशामध्ये असतो? आता फॉर्मिल ग्रुपचं स्ट्रक्चर काय आहे? CHO किंवा मिथिलचं स्ट्रक्चर काय आहे? CH3. असे जे ज्याच्यामध्ये कार्बन एकच आहे असे मॉलिक्युल्स फोलिक ऍसिडचं कोएन्झाईम टेट्राहायड्रोफोलेट ट्रान्सफर करतं, मेटाबॉलिक रिएक्शन्स मध्ये ट्रान्सफर करतं. So one carbon unit bind with the tetrahydrofolate at N5th or N10 position. Where is N5th? This is the N5th. Okay, or this is the N10 position. So this formyl group or methyl group, it binds to N5 or either N10 position and sometime binds to only N5 or N10 of sterol structure. टेरॉल स्ट्रक्चर कोणतं आहे? हे दिस इज द टेरॉल स्ट्रक्चर. तर टेरॉल स्ट्रक्चरच्या N5 ला ते बाइंड होतं 5th पोझिशनला. ओके, or on both N5 N10 of टेरॉल structure, the attachment of formyl at position 5, it forms N5 formyl tetrahydrofolate. जर 5th पोझिशनला नायट्रोजन जे 5th पोझिशनला आहे तिथे जर फॉर्मिल ग्रुप बाइंड झाला तर ते स्ट्रक्चर काय तयार होईल? इट विल फॉर्म N5 फॉर्मिल टेट्राहायड्रोफोलेट. जर 10th पोझिशनला बाइंड झालं तर इट विल फॉर्म N10 फॉर्मिल टेट्राहायड्रोफोलेट. Like this way, N5 methyl tetrahydrofolate or N10 methyl tetrahydrofolate. This is commonly known as folinic acid or citrohorum factor. So, do you get where this hydrogen atom binds? Methyl group or ethyl group binds to either this 5th position or 10th position to form methyl tetrahydrofolate or formyl tetrahydrofolate. So like this way it is involved in one carbon metabolism. The next vitamin is vitamin pyridoxine. So pyridoxine is also known as vitamin B6, or it is collectively there are the three derivatives, three compounds of pyridoxine: pyridoxal and pyridoxamine. These are the vitamins of B6. Vitamin B6, which is collectively represented by the three compounds. Which are that three compounds? Pyridoxine or pyridoxal or pyridoxamine. These are the three compounds which collectively known as vitamin B6 or pyridoxine, pyridoxal or pyridoxamines are also known as vitamins of B6. Which is vitamin B6? Vitamin B6 is the pyridoxine, but it consists of collectively three compounds: pyridoxine, pyridoxal and pyridoxamine. So occurrence, this vitamin is occur in animal sources such as egg yolk, fish, milk, meat. These are the rich source of vitamin B6. Egg yolk, fish, milk, meat. These are the rich source of vitamin pyridoxine. Wheat, corn, cabbage, roots, and tubers are the good vegetable sources for the vitamin B6. Wheat, corn, cabbage, roots, and tubers. These are also the good vegetable sources of the vitamin pyridoxine. Egg yolk, fish, milk, meat. These are the animal sources for the vitamin B6. So this structure vitamin B6, these compounds are the pyridine derivatives. Pyridine derivatives means they are the derived from the pyridine ring. They differ from each other in the structure of functional group attached to fourth carbon in the pyridine ring. Pyridoxine is primary alcohol. Pyridoxal is an aldehyde form, while pyridoxamine is an amine form. A pyridine ring have the derivative known as pyridoxal, pyridoxamine, and pyridoxal phosphate. Are you getting me? Vitamin B6, it is the pyridine derivative. That is, the ring is made up of pyridine ring. And they only differ with respect to functional group attached at the fourth carbon position. फोर्थ कार्बनला जो काही फंक्शनल ग्रुप अटॅच झालेला असतो त्या फंक्शनल ग्रुपनुसार त्यांचं they are there are different form of this vitamin pyridoxine or pyridoxamine. So which are that different form? Pyridoxine is the primary alcohol, that is the alcohol group is joined. Then pyridoxal is the aldehyde form of the pyridoxal vitamin, and pyridoxamine is the amine form. So these are the three different form of the vitamin, and these are mostly present in plant, while pyridoxal and pyridoxamine, these are found in animal food. These are found in animal food. So what are the coenzyme of this vitamin? The active form of vitamin B6 have the coenzyme pyridoxal phosphate, which is also known as PLP. And PLP can be synthesized from three compounds: pyridoxine, pyridoxal, and pyridoxamine. It is synthesized from three different compounds: pyridoxine, pyridoxal, and pyridoxamine. So what is the biochemical function of the vitamin pyridoxal phosphate? The coenzyme of vitamin B6 is found attached to the epsilon amino group of lysine in the enzyme. Pyridoxal phosphate, the coenzyme of this vitamin, it is found attached to epsilon amino group of the lysine enzyme. PLP is closely associated with the metabolism of amino acid. तुम्ही ऑलरेडी ट्रान्सअमायनेशन, डिअमायनेशन ह्या रिएक्शन शिकलेत. या रिएक्शन मध्ये बघा ट्रान्सअमायनेशन साठी काय लागतं? PLP, दॅट इज द pyridoxine, pyridoxal and pyridoxamine. कोणते तीन कंपाउंड आहे? pyridoxine, pyridoxal and pyridoxamine. So these are involved in transamination, decarboxylation, deamination and transsulfuration reaction. Which are that reaction? Transamination, decarboxylation, deamination, transsulfuration and condensation reaction. In all this reaction, this pyridoxal phosphate is involved. So first is the transamination. Transamination, pyridoxal phosphate is involved in the transamination reaction it is required for the enzyme transaminase converting amino acid to keto acid. We have already seen a transamination reaction. In transamination reaction, with the help of enzyme transaminase, amino acid is converted to keto acid and keto acid is converted to amino acid. So this transamination reaction, which is carried out by the enzyme transaminase, peridoxal phosphate is involved, which convert amino acid to keto acid. आपण ऑलरेडी ही रिएक्शन मेटाबॉलिझम मध्ये MB503 च्या पेपरमध्ये शिकलोय, ट्रान्सअमायनेशन, डीअमायनेशन. Okay, so this transamination involved the use of pyridoxal phosphate. Pyridoxal phosphate converts amino acid to keto acid. Again, that keto acid which are formed, they enter into the citric acid cycle and completely oxidize to generate energy. Thus, B6 is the energy releasing vitamin. Vitamin B6 दुसरं नाव काय आहे? It is the energy releasing vitamin. It integrates carbohydrate and amino acid metabolism. This vitamin integrates both carbohydrate and amino acid metabolism. During the course of transamination, PLP interacts with the amino acid to form pyridoxamine phosphate and the keto acid is liberated. What happened in the transamination? Pyridoxal phosphate interacts with the amino acid to form pyridoxamine phosphate, and pyridoxamine phosphate then donates amino group to keto acid. So keto acid is converted to amino acid and amino acid is converted to keto acid. आपण ऑलरेडी ट्रान्सअमायनेशन ची रिएक्शन शिकलेलो आहोत. Second is decarboxylation reaction. Some of the amino acid, they undergoes decarboxylation to form respective amines. Some of the amino acid, alpha amino acid, they undergoes decarboxylation reaction to form respective amine. This is carried out by group of enzymes called decarboxylase. Decarboxylation process is carried by the enzyme decarboxylase, which are depend on the pyridoxal phosphate. Then deamination of hydroxyl group containing amino acid required the pyridoxal phosphate. Mainly pyridoxal phosphate is required for the transamination and deamination reaction. Okay, so it is required deamination of hydroxyl group containing amino acid required pyridoxal phosphate as one of the coenzyme. Then enzymes of the glycogen phosphorylase that cleaves glycogen to glucose 1 phosphate, which require pyridoxal phosphate, one of the most important coenzyme, which is covalently bound to lysine residue. Enzyme glycogen phosphorylase, this is the important enzyme of glycogen metabolism. जर फिफ्थ सेमचं म्हणजे फिफ्थ सेमचं मेटाबॉलिझम चांगलं स्टडी केलं असेल तर या सगळ्या रिएक्शन, प्रत्येक कोणती रिएक्शन कोणत्या ना कोणत्या पाथवेमध्ये इन्व्हॉल्व्ह झालेली आहे. And these reactions are involved in this again chapter of enzymology. Enzymology consists of first unit, that is the vitamins and coenzymes. And coenzymes are made up of different vitamins. Coenzymes सगळे विटॅमिनचे डेरिव्हेटिव्ह आहेत. Coenzymes are the derivative of vitamins, and that coenzymes are actively involved in metabolic reaction. So this pyridoxal phosphate, which is the derivative of vitamin pyridoxamine. So this pyridoxal phosphate, it is involved in glycogen reaction of glycogen phosphorylase, which cleaves glycogen to glucose 1 phosphate. Then deamination of hydroxyl group containing amino acid, it also required pyridoxal phosphate. Decarboxylation reaction also required pyridoxal phosphate. Then transamination reaction, most important reaction of amino acid metabolism, it required pyridoxal phosphate. Transamination मध्ये काय होतं की amino acid 1 amino acid 1 plus keto acid amino acid 1 plus keto acid, these are converted to amino acid is converted to keto acid and keto acid is converted to amino acid. Okay, so these are the important vitamins and derivatives which are involved in reaction. So what we have seen. Now, what is the deficiency symptoms? Deficiency symptoms of pyridoxine includes neurological symptoms such as depression, irritability, nervousness, mental confusion, convulsion, and peripheral neuropathy, which are observed in severe deficiencies. Pyridoxine deficiency, it is associated with some neurological symptoms such as depression, irritability, nervousness, mental confusion, convulsions, and peripheral neuropathy. So these are the symptoms of the pyridoxine deficiency. These symptoms are related to decreased synthesis of biogenic amines. काही जे amines लागतात, that amines are low synthesized because of the deficiency of vitamin pyridoxine. So it is again one of the most important vitamin required for the metabolism. What today we have seen, folic acid. Folic acid folic acid is vitamin which is found in green leafy vegetable. Folic acid have Folic acid is rich in green leafy vegetable, whole grain, cereals, liver, kidney, yeast, eggs. Milk is the poorest source of folic acid. Folic acid consists of three components: pyridine ring, para-aminobenzoic acid, and glutamic acid. It have the most important active form, that is the tetrahydrofolate. The tetrahydrofolate is involved in one carbon metabolism in the metabolic pathways of carbohydrate, then amino acid, and nucleotide synthesis. It consists of three components: pyridine ring, para-aminobenzoic acid, and glutamic acid, and have the active form. Vitamin have the active form, that is the tetrahydrofolate. Okay, you again see the structure of pyridine ring with para-aminobenzoic acid with the glutamate. This is amino acid glutamate. Para-aminobenzoic acid and pyridine, this is collectively called as the teroic acid. Teroic acid with the glutamate, it forms folic acid, and it undergoes reaction by enzyme dihydrofolate reductase to convert it into the 5,6,7,8 tetrahydrofolic acid. So this 5,6,7,8 tetrahydrofolate, this is the active form of vitamin folic acid. So this is involved, this tetrahydrofolate, this coenzyme of folic acid, this is actively involved in one carbon metabolism. One carbon metabolism म्हणजे काय, की ज्या रिएक्शन पाथवे मध्ये एक कार्बन युनिट असतो, एक कार्बन युनिट इन्व्हॉल्व होतो. एक्झाम्पल, कुठे फॉर्मिल ग्रुप डोनेट करायचा असला किंवा मिथिल ग्रुप डोनेट करायचा असला, तर फॉर्मिल ग्रुप किंवा मिथिल ग्रुप हा एक सिंगल ग्रुप जर डोनेट करायचा असला रिएक्शन मध्ये, तर दॅट ग्रुप इज बाइंड टू टेट्राहायड्रोफोलेट, and that tetrahydrofolate transfer that group to the another compound. आपण याची रिएक्शन कुठे शिकलेलो आहे? दिस इज इन्व्हॉल्ड इन प्युरिन सिंथेसिस. प्युरिन सिंथेसिस मध्ये फॉर्मिल टेट्राहायड्रोफोलेट अशी एक रिएक्शन आहे बघा. तुम्ही प्युरिन सिंथेसिसचा पाथवे ओपन करा किंवा युट्यूब वरती प्युरिन सिंथेसिसचे लेक्चर बघा, त्याच्यामध्ये फॉर्मिल टेट्राहायड्रोफोलेटची एक रिएक्शन आहे. So this is involved in donation of one carbon unit. One carbon group is donated in the metabolism. The one carbon unit कुठे bind होतं? One carbon unit binds to the N5 position or N10 position or on the both. On both either N5 or N10 or both positions. म्हणजे ज्या रिएक्शन मध्ये दोन फॉर्मिल ग्रुप किंवा दोन मिथिल ग्रुप ट्रान्सफर करायचे असतील त्या रिएक्शन्स मध्ये दोन ग्रुप ट्रान्सफर होतात. द अटॅचमेंट ऑफ फॉर्मिल at position 5 it form N5 formyl tetrahydrofolate which is commonly known as folinic acid or citrohorum factor. Next vitamin is the pyridoxine. Vitamin pyridoxine is also known as vitamin B6. हे B1, B2, B6, B4, B5 हे जे नाव आहे B7 ते सगळे नीट लक्षात ठेवा. एक टेबल तयार करा आणि ग्रुपमध्ये टाका. प्रत्येकाने टेबल बनवायचा आणि ग्रुपमध्ये टाकायचं की कोणत्या व्हिटॅमिनचं कोणतं नाव आहे. कारण व्हॉट इज द अल्टरनेटिव्ह नेम ऑफ द व्हिटॅमिन असा क्वेश्चन येतो मल्टिपल चॉईस क्वेश्चन मध्ये. तर ते तुम्हाला तिथे ते कोणते अल्टरनेटिव्ह नेम्स आहेत ते सांगता आलं पाहिजे. सो व्हिटॅमिन B6 इट इज कलेक्टिव्हली नोन ॲज pyridoxine, which is three compound associated with the three compounds pyridoxine, pyridoxal and pyridoxamine. These three are collectively known as vitamins of B6. What is the occurrence of these vitamins? This vitamin occurs in animal source like egg yolk, fish, milk, and meat, and in vegetable source cabbage, roots, tubers, corn, wheat, etc. This vitamin structurally consist of pyridine derivative. याच्या व्हिटॅमिनचं स्ट्रक्चर मी ऍड करायचं राहिलेलं आहे ते स्ट्रक्चर मी ऍड करून देईल. Pyridine derivative, and it is the derivative of pyridine means when the primary alcohol group is attached to pyridine, it is the pyridoxine. When the aldehyde group is attached to pyridine, it is the pyridoxal, and when the amine group is attached to pyridine, it is the pyridoxamine. So amine group attached, it forms pyridoxamine. Alcohol group attached, it forms pyridoxine, and aldehyde group attached, it forms pyridoxal. So this pyridoxal, pyridoxine, and pyridoxamine, it collectively form vitamin pyridoxine. Okay, so this coenzyme, active form of this vitamin is pyridoxal phosphate, which can be synthesized from three compound pyridoxine, pyridoxal, and pyridoxamine. And what is the biochemical function of the pyridoxal phosphate? Pyridoxal phosphate have active role or active participation in transamination, decarboxylation, deamination, transsulfuration, and condensation reaction. Transamination reaction आपण मेटाबॉलिझमच्या फर्स्ट 5th सेम मध्ये शिकलोय. ट्रान्सअमायनेशन Unit 3, that is the catabolic pathway, catabolism of amino acid. Catabolism of amino acid have the transamination and deamination. So you once again you go through that and you see the reaction transamination. So pyridoxal phosphate is involved in transamination reaction by the enzyme transaminase converts amino acid to keto acid. Then next reaction is decarboxylation reaction. Third reaction is the deamination of hydroxyl group containing amino acid which require pyridoxal phosphate. Then glycogen phosphorylase, that is the enzyme of the carbohydrate metabolism, that is the glycogen metabolism. This glycogen phosphorylase cleaves glycogen to glucose 1 phosphate which required pyridoxal phosphate as one of the coenzyme. So what is the deficiency symptom of the pyridoxine? Pyridoxine deficiency is associated with the neurological symptoms such as depression, irritability म्हणजे चिडचिड होणे, मूड खराब होणे, डिप्रेस होणे, मेंटल कन्फ्युजन, काय करावं काय नाही हे कळत नाही, कन्व्हल्शन्स अँड पेरिफेरल न्यूरोपॅथी म्हणजे पूर्ण नर्वस सिस्टीमचं हे चेंज होतं. नर्वस सिस्टीमचे पेरिफेरल न्यूरोपॅथी म्हणजे associated with the nervous system disorders. So these symptoms are related to the decreased synthesis of biogenic amino acids. So next is the metal ions. Role of metal ions in uh, metabolism. So metal ions or enzyme associated with the metal ions are also known as the metalloenzymes. These are also called as metalloenzymes. So metal ions, these are essential for catalytic action of some enzymes. Essential for catalytic action of some enzyme. Metal ions are required for the catalytic activity. Metal ions contribute to the catalytic process through their ability to attract or donate electron. Metal ions काय करतात? They either attract electron or they either donate electron in the catabolism or anabolic process. म्हणजे enzymes requiring metal ion, they in that enzymes which require metal ions, the metal ion function either as a attract electron or either as a donate electron. So some metal ion binds the substrate by coordination link. Other contributes to maintain tertiary and quaternary structure of the enzyme molecule. Others are required to contribute to maintain the tertiary and quaternary structure of the enzyme molecule. Some metal ions maintain the structure of enzyme. Enzyme is made up of four level: primary level, secondary level, tertiary level, and quaternary level. So tertiary and quaternary structure of the enzyme molecule is maintained by the metal ion. So in metalloenzyme, removal of the metal component causes the loss of activity of enzyme. Removal of metal ion, it causes the loss of enzyme activity. So the enzyme which require metal ion, these include catalase, peroxidase, cytochromes. These are the hemoproteins in which ion is essential for the enzymatic activity. Which enzymes? Catalase, then peroxidase, cytochromes. They require metal ion. आता आपण सायटोक्रोमचं फंक्शन कुठे पाहिलं होतं? सायटोक्रोम ए, सायटोक्रोम बी, सायटोक्रोम सी, C1, सायटोक्रोम B3 in the electron transport chain. So we have seen the importance of ferrous. Fe2 is converted to Fe plus 3. Fe plus 3 is converted to Fe plus 2. Then Cu plus 2 is converted to Cu plus 3. Cu plus 3 is converted to Cu plus. So in the activity, enzymatic activity of cytochromes, these metal ions are required. Beside that, tyrosinase, ascorbic acid oxidase, cytochrome oxidase, it also required metal ions. Then carbonic anhydrase, alcohol dehydrogenase, these enzymes also required metal ions. Example, zinc, ascorbic acid oxidase, cytochrome oxidase required ferrous and copper. Carbonic anhydrase and alcohol dehydrogenase, they require zinc for their activity. Xanthine oxidase, which required ferrous ion, that is the ferrous ion. So most of the ferrous, copper, magnesium, zinc, these ions are metal ions are required for the enzymatic activity. Magnesium is required by the enzyme which use ATP as the cofactor. Magnesium is also required. Hexokinase enzyme required magnesium. Then those enzyme where ATP is involved, for the action of ATP, it requires magnesium. The active form of ATP is the ATP magnesium complex. ATP चा active form काय आहे? ATP magnesium complex. The magnesium binds to the negatively charged phosphate group of ATP. Magnesium कुठे bind होतं? तर negatively charged phosphate group of ATP. Then manganese is essential for the action of acetyl CoA carboxylase. Manganese is required for the action of enzyme acetyl CoA carboxylase. Then DNase and other enzyme, they require manganese. Then glutathione peroxidase, this required selenium ion. Glutathione peroxidase, this enzyme required selenium ion for the activity. Then most of the enzyme required calcium ion for their activity. So the activity of enzyme depends on the presence of certain ions in the medium, such as cations, Na plus or K plus, or the chloride minus ions for the activity. So with this we have finished the first unit of this MB603 paper. So this first unit include role of cofactors in metabolism and action of different coenzymes. That coenzymes are associated with the vitamins. कशा बरोबर असोसिएट आहेत ते? विटॅमिन्स बरोबर. So these are associated with the vitamins, and that vitamins you have to study the structure of vitamin as well as the structure of their active coenzyme also. हे तुम्हाला लक्षात राहायला पाहिजे, कारण ते एक तर मल्टिपल चॉईस क्वेश्चनला येईल. आणि इफ यू हॅव टू राईट युअर थेरी पेपर, देन ड्रॉ द स्ट्रक्चर ऑफ विटॅमिन रायबोफ्लेविन और आयदर ड्रॉ द स्ट्रक्चर ऑफ एफएमएन और एफएडी. एफएमएन किंवा एफएडीचं स्ट्रक्चर ड्रॉ करायला येईल, किंवा एनएडीचं स्ट्रक्चर ड्रॉ करायला येईल, किंवा बायोसायटिनचं स्ट्रक्चर तुम्हाला ड्रॉ करायला येऊ शकतं जर तुम्ही डिस्क्रिप्टिव्ह पेपर लिहिला तर. आणि जर तुम्ही ऑब्जेक्टिव्ह पेपर दिला तर ऑब्जेक्टिव्ह पेपरमध्ये ते कोणत्या व्हिटॅमिनचं कोणतं कोएन्झाइम आहे हे त्याच्याबरोबर असोसिएटेड असेल, आणि असे मल्टिपल चॉईसचे क्वेश्चन असतील. सो यू हॅव टू स्टडी धिस विथ थरोली तुम्ही हे स्टडी करा. ओके. So with this I have finished the first unit. If you have any difficulty, you can send your difficulty on the group.